Okay, so we're going to go over rearranging formulas, and this is also known as solving literal equations. Basically, sometimes we want to solve things when they're already in like letter form, and we don't want to plug in any numbers. And I'll talk about why. So our goals for today are to be able to solve a linear equation, and so we're just refreshing our ability. We're trying to like keep going and keep practicing with that. We also are going to want to be able to solve or to rearrange a formula to be able to solve for a certain variable. So a literal equation, literal in our case means of or in, or of in or expressed by a letter or the letters of the alphabet. So in other words, our equation is going to be composed of letters and not any numbers. It's a little bit like it throws you for a loop, but once you get used to it, it's just easy peasy. Sometimes the reason that sometimes we want to rearrange these formulas while they still have letters in them. Now, the great question is why? And the simple answer is the fact that we're lazy. So formulas are made so that they can model every single possible combination that exists. For example, if you want to find the circumference of a circle, you have a certain formula. Now, you could solve it once and you'll get it for a very specific circle. But if you wanted to, say, have something that will work for every single circle that exists in the universe, no matter how big or how small, you can rearrange a formula so that it will solve for a circumference and then you're happy with it. You don't have to do any other work. You just have to plug in the numbers that you have and chug them out. So by rearranging the formula once, we save time and math for ourselves. Let's refresh in the problem solving process really quick. We're going to identify the variable. Now this one is a really important one for now for solving literal equations because you're going to have a lot of letters in it. You need to know what letter you're actually solving for. Sometimes the one that you think is going to be the variable that you would normally solve for isn't, and so you have to know exactly what variable you're solving for. You're going to want to simplify each side if possible. This will be a little bit harder to do because you don't actually know what numbers the letter represents. But if you had like b plus 2b, then you could combine those to get yourself like a 3b and make yourself lives easier. You're going to move your variable to one side like you always do. You're going to isolate the variable. Remember, you're going to go easiest to hardest, so undo addition and subtraction first, and then you're going to undo multiplication and division. Then you're going to plug it in, chug it out, and check. And if you need to, you can plug in the end, like if you're given certain values for these letters, you can plug in those values at this point, chug it out, and then check and see if it makes sense. So we're going to rearrange some formulas. And remember, we need to identify the variable that we are actually solving for. There's going to be a lot of letters in here, and not all of them are going to be variables that we're actually like trying to solve for. We need to treat every other letter that's not our variable as if they're just a number. So they're just representing a number, and we can say that we know it. We just haven't been given that information yet. And we need to just solve the equation like we normally would. Now on the right, you'll see that we have this list of like all these are the same formula. So these all come from this first one, which is c is equal to 2 pi r, right here. Now, if you were to solve this for pi, and by solving it for pi, you divide it by 2r, because that's what's being multiplied into the pi, you'll get the circumference over 2r, and that will give you pi. Now, if you're solving for r, the radius, then that'll equal to the circumference divided by 2 pi. So if you ever have a circle and you want to find, and you know how like long its circumference is, so you know how much fence you can put around it, you could figure out how big the radius is by using this equation right here, and you wouldn't have to go through and plug it in and resolve it. So here's a video. I'm not going to show it to you. I will link to it. It's called, it's something along the lines of calculating pi with real pies. It's by Numberphile. It's a really good one. He goes through the process of calculating the number pi by solving a literal equation and then finding some values using actual pies as units. Let's try this rearranging one. We're going to do two of them. We're going to try them out. So we have the equation y is equal to mx plus b. This is our famous slope-intercept form. You're really used to this one. Now, part of the problem here is so we had to go through and identify the variable, because if you notice that we have this x, generally we think, oh, x is our variable that we're solving for, but here it tells us to solve for m. So m is our variable, and we need to make sure that we're talking about m. We can't really simplify anything because we don't know any of the numbers. So I'll talk more about that in one of our next steps. The variable is already on one side, so we're good there. So now let's try and isolate this variable. First thing that we're going to want to do is we're going to want to do the easiest, we're going to want to undo the easiest thing. First, the easiest thing that we can undo is get rid of this plus b. The way to undo addition is by subtracting, so we're going to subtract b from both sides. And we're going to get y minus b is equal to mx. You notice that I didn't try and combine anything in there, and that's because we don't know the actual values of y or b. We want to leave it like this so that we can plug them in when we need to, but since we don't know them, we can't actually do it. So like say if y was 5 and b was 2, we could easily do that math. 5 minus 2 is 3. But here we don't know that because y could be 5, it could be 6, it could be 7, so we're just going to leave it as it is. Our next step here, remember we're solving for m, is that we're going to get rid of that multiplication that we have in there. So we have m times x. We want to get rid of that x. We want m all by itself. The way to undo multiplication is to divide. So we're going to divide by x from both sides. And then our answer is going to be m is equal to y minus b over x. So our y minus our intercept divided by our x value. Now let's say that we're given y is equal to 2, b is equal to 1, x is equal to 1. Well, we can plug this into here, and so we'll get 2 minus 1 over 1, and that's just going to give us a value of positive 1. So our slope in this case would be positive 1. Now, if we have y is equal to 5, b is equal to 3, x is equal to 1, so you notice that the only things that we changed for the y and the b, we left the x alone, but we can still plug this in. And so our y is equal to 5 minus our b, which is 3, divided by 1. Here's our green slope. And that's going to give us an answer of 2. So you notice that we can use this equation now that we've rearranged it to solve for the slope easily because we don't have to resolve it. We just have to plug in the numbers and go. We're going to do another one really quickly. This one is for physics. This is from physics. And what it's saying is that your final velocity, your final speed, is equal to your initial speed plus your acceleration times your time. So if you're starting out from rest, so like you're at a stoplight, and so your initial velocity is 0. Then you accelerate really fast for like 3 seconds, and then you can find out what your final velocity would be. So we are going to solve for VI, our initial velocity. So we're going to say VF is equal to VI plus AT. Remember identifying our variable there. We can't simplify anything. It's already on one side. So all we have to do is isolate it. Here what we're going to do is A times T. We are happy to just divide or subtract that out. We don't have to do anything else. We don't have to divide anything out of that. And here's why. A times t, so what if instead of a times t we had 3 times 2? Well, 3 times 2, that becomes a 6, and we can just divide by a number, 6, and that's fine. So our a times our t, because they're both numbers, they'll multiply together, they'll both become another number. We can just divide by a number and we're happy with, or we can subtract by a number and we're happy with that. So our final answer here is that our final velocity or final speed is equal, final speed minus our initial speed, our final speed minus our acceleration times our time. So how fast we're speeding up times the amount of time that we're speeding up is going to be equal to our initial speed. And so we're happy with that because now we can just plug in any values that we need to, and get our initial speed without having to go through all the work. So here's a quick check. It's just to rearrange each equation for the given variable. You'll notice that it tells you what one to solve for. So in this case, it's solving for t. So there's your t. Make sure you're going through the problem solving process and like identifying the variable that you need to solve for. Yeah, so here's your quick check. Have fun with it and take as much time as you need with it.